Okay, this is your lesson on the chain rule. The chain rule is where you're going to be able to do more complicated derivatives, and when they're kind of embedded in each other. And your text says, this is a more powerful differentiation rules, and they work on compositive functions. Okay, so this is going to help a lot in doing some really challenging things like the problems that you see here without the chain rule on the left column, and then with the chain rule on the right column. You can see that this is going to be a composite of functions, meaning that it's going to be like f of g of x. You can have one function inside the other. Now, if you're looking at this function here, y is equal to radical x squared plus 1, can you see that there's a blob in here? There's a blob in here inside the square root. So we're going to say that one function is going to be that blob thing, and then f of x will be the square root of that blob, so that when we take the composite of functions, we put one inside the other, then we're going to get this function here. Okay, so what function do you think would be on the outside, and what do you think would be inside? So I think that there's a blob in here. Okay, so that blob would be 6x. So that blob would be 6x that gets put into the x for the f. So we're going to put one function inside the other to make this. So we can separate it into two separate functions, work with them separately. Now this is a good example of most of the time the blob is going to be whatever's in the square root, in the parentheses, most of the time. Okay, so in this case the blob was in the parentheses, and then what's on the outside, what we do to that blob is we take it to the 5th power. Now this one kind of trips people up a little bit, and just remember that tangent squared x is not the same thing as tangent x squared. And then you have this other thing hanging out here. Okay, just remember that when you take a derivative of a sum, it's just the sum of the separate derivatives. So we're going to separate these separately. So we're just going to look at the tangent of x squared. So that blob is going to be x squared, and then the tangent of that blob would be the f of x function. And what about this x over here? That's just another function that's going to hang out by itself, because it's going to actually look like this: h of x plus g f of g of x, if that makes sense to you. All right. Okay, so when we take the derivative, we do h separately, and then we use what we call the chain rule on this composite of functions on the tangent of x squared. All right, let's look at this. We're going to call g of x what's inside, and we're going to shorten it up to just say u and f of u, which is a lot easier to write than f of g of x. Okay, so this is f of u is what we're going to be dealing with here. So what do you think would be the blob here? The blob, I think, should be the x plus 1, which means that the f function, what do we do to x plus 1 to get 1 over x plus 1, which will be just 1 over the u. Okay. What about this one? What would be the blob? The blob should be what's inside, and then what's on the outside is actually the sign of that blob, the u. And then this one, the blob would be what's inside, and then we have the function of that blob would be the square root of that blob. Okay, and what about this one? Okay, now be careful. This is not like the last one. Remember I said x tangent of x squared is not the same thing as tangent squared of x. Tangent squared of x really looks like this. So you got to be careful. So what is the blob this time? The blob is the tangent of x, and then the function on the outside of tangent of x would be the squared term. Okay, so we squared this to make this and then we write tangents or trig functions like this. So it's kind of misleading a little bit sometimes. All right, continuing on. This is the technical way of writing this, or the way we're going to actually take the derivative. We're going to take the derivative of that outside. So we're going to do the derivative of f first, leaving the blob the way it is. And then we're going to take the derivative of that inside function. Okay. So this is just another way of writing this thing here, and we'll get more into this notation later. But right now, just remember we're gonna take the derivative of the f, leaving the inside function alone. Then we're gonna multiply it by the derivative of that function. Okay, here's what I'm talking about here. Here's an example. Okay, this is what we're going to do right now for this example. So we're going to identify the inside function, the u. The u is going to be x squared plus 1, and we use u and g of x interchangeably. U is just the function on the inside. And then what's on the outside? Well, that would be just x cubed, because we put this function inside here to make this function. Okay? And they purposely throw all these different notations around so that you can get used to all the different ways that you might actually see it on the AP exam. So now what we do is we take this derivative, leaving this alone, and then we take the derivative of this and multiplying it. So we're going to take this derivative, so we're going to take the 3, put it in front of my blob, my inside function, and then reduce the exponent by 1. How's that? Put the 3 in the front, leaving this intact, leaving this g of x inside unchanged, and we reduce the 3 by 1. Now we have to do the chain part. The chain part is take the derivative of the inside, which is 2x to the 1 plus 0. So it's just 2x. And that's the derivative. That's it. That's the chain rule. It's not too bad, except you just have to remember to do it and recognize it when you see it. That's the hard part. The actual work on it, the algebra on it, is not hard, is recognizing when to use it when you see it. Okay? All right. And then we always combine our terms that are alike. 3 times 2x, put that in the front, make it nice and pretty. Okay? Final answer. All right. So I'm actually not that fond of all this notation. What I said there was enough, but for you math people out there who like math notation, I'm going to give you this because I'm supposed to give it to you, and you can write it down if you want. You may never look at it again, but this is just this. Remember this part right here? That's tells you to take the derivative of u to the n. That means you're going to take the n, put it in the front, minus 1. And then this part just reminds you, if this is a function, if u is a function, you also have to take the derivative of that and then multiply it to the derivative of that. So this, we call this a general power rule because there is a chain rule hidden inside of it. All right, so let's do another one. Okay, so here, what's inside here is my u. See, we switch notation again, and the first problem we call this y, and then we call them f of x and g of x. Now, since we call this f of x, we can't use f of x again, so we're going to call it u and y. So they're interchangeable. So this is the blob inside. So the y is going to be the function on the outside, the cube. Okay? So now we're going to treat it as a blob. So if we treat this as a blob, then taking the derivative would be, put the 3 in the front, 3 times the blob to the 2 second power, because we're going to subtract 1 from the 3. Then remember to take the derivative of that blob, the u, and multiply it on the end. So you're going to take the derivative of this, and this will be 3, throw away the x, minus 4x. Now you shouldn't distribute the 3 onto any of this thing, okay? Everything should be factored when possible. All right. Find all points on the graph of f of x for this function, the cube root of x squared minus 1 squared, for which the derivative is equal to 0, and for those which the derivative does not exist. Okay, so I'm just going to remind you that this right here is actually an exponent. Because you're looking at that, you may not be able to see the exponent. Okay, let me go back. Okay, try and find the exponent on this. Okay, the exponent is that. I know that may be hard to see, but learn to see that as the exponent. Then your life will be a lot easier. There will be less confusion in your problems. Okay, so your blob, like I suggested to you before, is usually what's in the parentheses. Well, if you remove that parentheses, you can check to see if that can be written in a exponent. And it can, because that's going to be 2 squared, right? 2 squared. And then there's a cube root. Put that in the denominator. So now there's your two functions, your y and your u. Now remember that I'm going to take the derivative of just the y part. We take the 2/3, put it in the front, subtract 1 from 2/3 is equal to negative 1/3. Don't get confused by the fractions, okay? And then we're going to take the derivative of the u and we'll multiply it. So the derivative of the u would be 2x. Okay, I want to clean this up a little bit. Take the 2 times the 2x, make 4x over 3, and since this is a negative 1/3, that has to go in the denominator. Okay, this part right here has to go in the denominator because it has a negative exponent, and the 1/3 means you take the cube root. This 3 is that 3 right there. It's not 3 to the 3rd power, but it's a cube root, just like this cube root, and this is 2x times 2 is 4x. Now, back to the problem. Find all points where the derivative is equal to 0. We want to find where this is equal to 0. We're looking at a bunch of stuff. How can we make this 0? By making the numerator 0, right? As long as the numerator is 0, this is 0. So if we can make the numerator 0, we found where the derivative is 0. Okay? So the derivative is 0 when the numerator is 0. So that means that x is equal to 0, that's when the derivative is equal to 0. That means this is where the slope is horizontal. And you're also going to find where the derivative does not exist. That means that we're going to look at the denominator now. If the denominator is equal to 0, then the derivative does not exist. So we're going to solve that. So we're going to have this, divide both sides by 3. Get rid of the cube root by cubing both sides. I cubed 0 and I got 0. Subtract the 1. Take the square root. But make sure when you take the square root of a square, you're going to get a plus or minus. So this is where it's 0, and this is where it does not exist. This is where the slope is going to be vertical. It'd be kind of fun if you look at this on your graphing calculator to see what it looks like. Why would it have a 0 slope here and does not exist in the 1 and negative 1? Okay, one more example. Why don't you pause this? I think it would be a nice challenge for you to kind of break this apart and do this by yourself, and then come back and check. And you can always look at just pieces of the video and then continue if you made a mistake. But it's always good practice. Remember, lots and lots of practice. Don't just sit here and watch because you won't get enough practice. All right, first step, find your u. The u is 2t minus 3. Okay, that means the y is negative 7 over x squared. Okay, now we're ready to start taking the derivative. We're going to take the derivative of y, which I'm going to rewrite y as negative 7 x to minus 2. Remember, the negative 2 means that I move the x to the denominator or the numerator because it's in the wrong place. Now I'm going to take the derivative of this, take the negative 2 times negative 7, get a positive 14, minus 1 from the negative 2 and get a negative 3. Leave the u alone, and then take the derivative of the u, put that in the back, and then just clean it up by multiplying it with the front. I hope you got that. That was awesome if you did. That is pretty cool, and that means you understand how to use the chain rule. Make sure you do the Google form. Oh, by the way, I'm sorry, I forgot. You don't write answers with a negative exponent, so just put that back under here. And don't forget to do the Google form, and maybe check out your book and see some problems in there. Try a few before you see me tomorrow, so you have lots of great questions. All right? Okay.